Hey guys, how are we doing today? We're going to do section 13-5, which is the cosine function. We did 13-4 last week, and it was the sine function. I showed you how to graph both the sine and the cosine function. And the cosine function, again, obviously you're going to be taking these notes down, and then there's going to be an assignment afterwards. I'm going to be giving you guys a quiz. This assignment is going to be due Monday, coming up Monday. And I'm going to be giving you a quiz on Tuesday on section 13.4, which is graphing the sine function, and 13.5, which is the cosine function. The quiz is going to be almost identical to the homework that I give you. Whatever homework I give you, the quiz will be very identical to it. And it'll be kind of short, just, like the usual. The cosine function, again, y equals the cosine of theta, matches the angle measure of theta, which could be in degrees or it could be in radian measures, to the x-coordinate of the point on the unit circle. If you remember the unit circle, you guys should have a copy of the unit circle now and keep it handy, because this is what you need to find the outputs given any input. The inputs would be the degree measures or the radian measures. The outputs are going to be either the x or the y coordinates. For sine, it's the y coordinate of the point on the unit circle. For cosine, it's the x coordinate of the point on the unit circle. The exact answers are here in these points, and then if you want the approximate answers, you just have to divide them and get the approximate answers in decimal form. But right now we're looking at the exact answers. So if we look over here, let's start example 1. Example 1 is asking us, given the cosine function, this is the parent function for the cosine, the difference between sine and cosine is the sine always starts in the middle, between the max and the min of this function. The sine and cosine look identical. The cosine starts at the max or the min. If it's a positive cosine of theta, it starts at the maximum. How do you get the max and min? You look at the amplitude, the number in front of cosine, and that's A. In this case, there's nothing there, so it's a 1. So the max and min are 1 and -1. That's how you know. And then it follows the same exact pattern as sine, except it starts at the max or the min. If it's positive, it starts at the maximum. If it's negative cosine theta, it will be the same graph, except it will be reflected across the x-axis, and it'll start at the minimum of -1. Okay, so anytime you graph sine or cosine, what you want to do is find the period, one cycle, okay, and then you want to divide that. The period is the length of one cycle. Once you find one cycle, you divide that by 4 to find the 4 main parts of the graph. Some of them are max and mins, like max, min, max. Some of them are x-intercepts, which are called zeros, these two here. Those are the 4 main parts. Once you divide the period by 4, you get these 4 main parts. In this case, if I divide 2 pi by 4, I get, let me do that in pencil. 2 pi divided by 4, because the period of the cosine function is 2 pi. If you divide it by 4, you get these 4 sections. If you divide 2 pi divided by 4 and reduce it, you get pi over 2. So what you're doing is you're adding pi over 2 from the beginning to the end. So 0 plus pi over 2 is pi over 2. Plus pi over 2 again, you get 2 pi over 2, which is pi. Add pi over 2 again, you get 3 pi over 2. Which you can't reduce, so keep it 3 pi over 2. Add pi over 2 again, you get 4 pi over 2. Isn't 4 pi over 2 2 pi? That's where we got these 4 sections from of the graph. Now that we have the 4 sections, we can go on the unit circle and find out what all these equal. The cosine of 0, if theta was 0, the cosine of 0 would be the x-coordinate, 1. Cosine is 0. The cosine of pi over 2 would be the x-coordinate, 0. The cosine of 180 degrees, or pi, is -1. The cosine of 270 degrees, which is 3 pi over 2, is 0, the x-coordinate. And the cosine of 2 pi, or 360 degrees, is, again, 1. That's where I got these numbers from. Okay, this is the parent function of the cosine graph. Okay, now that we have the graph, what we're going to do is, example 1 is find the domain, period, and amplitude of the parent function of the cosine. So the domain is going to be all the x values that are possible in this graph. We just graphed from 0 to 2 pi, but this graph does go on forever in both directions, and it keeps repeating. It's a periodic function. So the domain is going to be all real numbers. Remember how to write all real numbers in interval notation? Negative infinity to infinity. You can write it like that, or you can say all real numbers, doesn't matter. The period is going to be the length of one cycle, which is x2 minus x1. This cycle starts at 0 and ends at 2 pi, so basically the period is 2 pi minus 0, which equals what? 2 pi. Yes, 2 pi. So the period is 2 pi. The domain is all real numbers. The amplitude is 1/2 the max minus the min. The max is 1, the min is -1. So the amplitude is 1/2 1 minus -1, which is 1/2 times 2, which equals 1. The amplitude is 1. Yeah, that's the amplitude is A, if you remember, when we talked about sine. So A is equal to 1. It makes sense, because look, the number in front of cosine is nothing, so it's 1. So we got those answers. Then it says find the max, min, and zeros of the same function. The max is the maximum value, which is 1. The minimum is going to be the minimum value, which is -1. The y value is -1. And the zeros are the x-intercepts. Where do they occur at? At -1 and 1. 1 second, let me do this real quick. And the zeros are 0, 0, right? Except what we have to do is, where did it occur? The zeros are where it equals 0. Where did these occur? The one occurred at x equal to, theta. You got to say where it occurred at. So the maximum occurred at theta equal to 0, and it occurred at 2 pi. This is the answer right here. Where'd the minimums occur? Well, there's only one minimum, and it occurred at theta equal to pi, or 180 degrees. This would be 0 degrees. This would be 360 degrees. If you see that, good. And then where did the zeros occur? They occurred in 2 places, where x was equal, or theta was equal to pi over 2 and 3 pi over 2. That's where the zeros occurred. This is the minimum occurred at pi. The minimum occurred at pi. The maximum occurred at 0 and 2 pi. The zeros occurred at pi over 2 and 3 pi over 2. The answers are the x coordinates, or in this case, theta, the theta coordinates. Now I want you to do quick check number 1 on page 477, very similar to example 1. I'm going to continue on to example 2 and then example 3, and then we're done. We're not doing example 4. Make sure this is lined up right. You see everything, hopefully. That looks good. You can see the homework on the top right-hand corner, and it's going to be due this Monday. I think you can see everything now, right? Let me see. Make it a little smaller. Okay, we're good. Okay, example 2. How does A affect the graph of the cosine? Y equals A cosine of B theta. A affects the vertical stretch. So it's also the amplitude. So let's look at example 2. Example 2 says graph y equals 1.5 cosine of 2 theta. So A is the amplitude. This is A. Remember, it's y equals A cosine of B theta. So we're going to find out what A and B are going to help us graph this whole function. So A is the amplitude. It's just going to simply give me the maximum and minimum. I already know that my graph is going to be a maximum of 1.5 and a minimum of -1.5. I got that from A. Then the period we know equals, this is the formula that we learned last time, the period equals 2 pi over B. B is the number of cycles from 0 to 2 pi. And they will also, by the way, they want us to graph this from 0 to 2 pi. The first thing you do when you graph any of these functions is you have to find the period, because the period is one complete cycle. So in the cosine, the cycle starts from the maximum and it's going to end at the maximum. If you look over here, you have 2 cycles from 0 to 2 pi. So let's look at that. Okay, let's go back over here. We're going to have to find the period equals 2 pi over B. So I did the work down here for that. Okay, here is the amplitude is 1.5. I already figured that out. Maximum or 1.5, -1.5. The period is going to be, well, we know what B is. B is 2. B is going to help us find the period. And the period is going to be 2 pi over 2, which equals pi. So the period is pi. That means one complete cycle is going to start at 0 and end at pi. But they asked us to graph this from 0 to 2 pi, so guess what? We're going to have one 2 complete cycles from 0 to 2 pi. Let me go back to this period that we just found. The period is pi. Whenever you find the period, you still have to break that period into 4 equal parts. And these 4 equal parts, you just simply divide the period pi by 4. So whenever you find the period, divide it by 4 every single time. And that's pi over 4. Then starting at 0, just keep adding pi over 4 to get your 4 sections. I'm going to keep adding pi over 4 all the way through this graph from 0 to 2 pi to figure out what my sections are. And each period has 4 sections. So add pi over 4 to 0, you get pi over 4. Add pi over 4 to pi over 4, you get 2 pi over 4. Add pi over 4 again, you get 3 pi over 4. I'm going to reduce these later. Add pi over 4 again, you get 4 pi over 4. Keep adding pi over 4. That's 5 pi over 4 is next. Keep adding pi over 4 until you finish it from 0 to 2 pi. Add pi over 4 to 5 pi over 4, you get 6 pi over 4. Add another pi over 4, you get 7 pi over 4. Add another pi over 4, you get 8 pi over 4. And if you reduce a lot of these different fractions, you'll get the numbers I got at the bottom. So let's reduce pi over 4. You can't reduce it, it's pi over 4. 2 pi over 4 reduces down to pi over 2. 3 pi over 4 stays the same. 4 pi over 4 becomes pi. 5 pi over 4 stays the same, you can't reduce it. 6 pi over 4 you can reduce to 3 pi over 2. 7 pi over 4 can't be reduced. 8 pi over 4 is 2 pi. That's where I got my sections. Again, from 0 to pi was 1 cycle. They wanted us to graph from 0 to 2 pi, so there's 2 complete cycles. And we know that cosine is always going to start at the max or min. Since it's positive 1.5, we're going to start at the maximum of positive 1.5. And then at each one of these intervals, at each one of these little intervals that we found, there's either going to be a 0 or a minimum or a maximum. Maximum, 0, minimum, 0, maximum, 0, minimum, 0, maximum. When I say 0, I'm talking about the x-intercepts. So you just follow that pattern and it goes on forever. And then draw the curvy lines. Again, it looks exactly like cosine. The only difference is it starts at the max or min instead of starting at the midline in the middle. So this is the graph of y equals 1.5 cosine of 2 theta. Again, you got to get these numbers by first finding the period, then dividing the period by 4, and then keep adding that number, pi over 4. It's going to be different for each graph. Keep adding that number. At the end, you can reduce them to figure out what they are. Okay, now that you did this, go ahead and do quick check number 2, page 744. A and C, you can skip B. You don't have to do B. So you're doing A and C only. A and C, not B. You're skipping B. Okay, so let's look at example 3. Example 3, I didn't really do it exactly like the book. I changed it a little bit. So I did an A and a B. So this is example 3 I created. It says write a cosine function for each description. If you know the amplitude and the period, can you write a cosine function? So to write the cosine function, you need 2 things. You need to know what A is, and you need to know what B is. If you're given A, that's fine. You just put it here in front of the cosine function. If you're given B, you're good. You just replace it with B. In this case, we were given the period, so we're going to have to find B. How do you find B given the period equals 4? Well, here you go. Period, here's the formula. Period equals 2 pi over B. So the period is 4. I replace period with 4. 4 equals 2 pi over B. All we have to do is solve for B, and then we have A and B. Once you have A and B, you got the equation. So we're going to solve for B. We're going to solve this equation for B. So I'm going to multiply both sides by B, get 4B equals 2 pi. Then divide both sides by 4 to get B by itself. You get 2 pi over 4, which is simply equal to, reduce it, pi over 2. So B is pi over 2. A is 5. I'm done. All I have to do is replace A with 5 and then B with pi over 2. I'm going to write my function down in red down here. Y equals A is 5, cosine of pi over, and B is pi over 2, theta. This is the answer for example 3A that I created. Let's do example 3B that I created. Same thing. If the amplitude is 2 and the period is 4 pi, what's the equation? Remember, we need A and B. We already got A. A is 2, so we'll replace it with A down here. What we need is B. We were given the period, so we're going to have to find B. We know the formula for period is period equals 2 pi over B. So now that we know that, we can replace 4 pi with the period. 4 pi equals 2 pi over b. Now we can simply solve for b. So let's go ahead and do that. I'm going to multiply both sides by b first to get b b on the correct side. B times 4 pi equals 2 pi. Then divide both sides by 4 pi to get b by itself. B equals reduce. The pi's cancel out. This is simply 1/2. B is 1/2. So we have a is equal to 2 and b is equal to 1/2. All we have to do now is write the equation. Y equals 2 cosine of 1/2 theta. That's the equation here. So again, to get the equation, given some information, the amplitude and the period, all you have to do is replace the amplitude with A, and then if they give you the period, find B. If they give you B, you're done. All you gotta do is replace A and B in this equation. Okay, so I want you to do quick check number 3, page 745. And again, it's gonna be A and B. And also, you should be able to look at a graph and be able to find the amplitude and period. We already know how to do that. Once you find the amplitude and period in a graph, you can write the equation of a graph. So that's going to be in the homework. Okay, now we're good. After you do quick check 1, 2, and 3 and copy all the notes, now you're ready to do the homework. And the homework is homework number 9, page 746, 1 through 14 all. Your quiz will be Tuesday, and it'll cover section 13.4 and 13.5, they're very similar. One's sine and one's cosine, graphing them and writing equations, all that good stuff. Look at the homework, review the homework, and the quiz will be Tuesday. Thanks, guys.